This is question 39 from the 2017 exam.
In this question, we are given a cubic polynomial with two constants, unknown constants p and q, which we have to determine using the fact that this function y of x has a maximum at x equals 2 and a minimum at x equals 4. So remember that these are stationary points, and they occur when the derivative of that function is equal to 0. So it seems like a good idea to start by differentiating this function with respect to x, so that's what I've done here. And we'll set this to 0. And in this line, we see the whole polynomial divided by 3, so in the standard form, where the coefficient of x squared is 1. And we know that for a quadratic equation in this form, the linear coefficient is the sum of the negatives of the roots, and this constant coefficient is the product of the negative of the roots. And because we know that the two stationary points are at x equals 2 and x equals 4, the roots have to be 2 and 4. So we can write these two facts in two equations, one for p and one for q, and solve for these two constants, which we are supposed to do. And that gives us that p equals -9 and q equals 24, which was one of the options in the exam, namely D. Now all this relies on you knowing that this will be the sum and this will be the product of the roots in a quadratic polynomial, which you might just not recall in the exam. So of course there is a most straightforward way to do it, even though it requires a bit more calculation. We know that 2 and 4 are roots, so we substitute 2 and 4 for x, one after the other. We should get simultaneous equations in p and q. And this is what happens when we substitute 2 and then 4. We do get simultaneous equations in p and q, and when we solve these, again, we get p equals -9 and q is 24, which was D.